So hello everyone, first test, can you hear me?
From the Guyana Space Center in Kourou.
Hello everyone, today we will be watching the launch of an Ariane 5 built or operated by Ariane Space, built by Ariane Space and Airbus Defence and Space. It is an Ariane 5 ECA rocket designated VA238, which is just the upcounting number of Ariane 5 rockets. The rocket will launch two satellites in tandem, which is quite usual for the Ariane 5 rocket, one of which has several names or designations. It's an Inmarsat S-band satellite, also known as GSAT 3 or condosat, which is a bit tricky. The other one is much simpler, it's just called GSAT 17. Both are basically communications satellites. GSAT is just a normal ground-based communication satellites for telecommunications and television over India, and Inmarsat or HeLaSat or condosat is actually another off-grid Wi-Fi satellite that provides a radio connection on uplink to airplanes and also ships, possibly, but mostly airplanes, so that you can have Wi-Fi on ships and airplanes, and the airplane's own radio system essentially connects to the satellite over the satellite to the internet and gives you Wi-Fi. The satellites will, as is common for communication satellites, be launched in a geostationary transfer orbit, and that is a rather standard mission for the Ariane 5. It has about rather heavy load to geostationary orbit. It's optimized for geostationary orbit, and it can easily pack two standard satellites to geostationary transfer orbit in one launch. The launch is scheduled for about 9 p.m. GMT, but the launch window extends over 1.25 hours. We can, however, expect and hope the launch to be on time, that is, at the beginning of the launch window.
Greetings to all of our friends around the world, and welcome once again to Kourou, the home of the Ariane family, for today's live broadcast of Ariane space flight number 238. We're very glad you could be with us all for the mission tonight. We're launching 2 satellites, one of which has 2 operators. Very unusual. To get us underway, we're going to go first for some opening words to Ariane Space Chief Executive, Stefan Israel. We spoke to Stefan at the Paris Air Show.
Dear customers and partners, ladies and gentlemen, I wanted to benefit from the Paris Air Show to make this introduction for a very special launch. Indeed, Ariane Space is delighted to welcome you from the CSG for this new Ariane 5 mission, the 4th of the year with our heavyweight vehicle. For this mission, we are going to launch 2 key satellites for customers and partners. Elasat 3 Inmarsat SEAN, a condosat for the Elasat and Inmarsat operators. The satellite has been manufactured by our long-standing partner, Thales Alenia Space. GSAT 17 for the Indian Space Agency ISRO, who also built the satellite. Thanks to Elasat, Inmarsat and ISRO for your trust. Ariane 5 is now on the launch pad after having been transferred yesterday. All the operations linked to the final countdown went well, so we should be in a position to launch at 5:59 p.m., the time of the opening of the launch window, which will last 1 hour and 17 minutes. The overall performance to GTO required for this launch is 10 tons, 177 kilos. As you know, the liftoff occurs 7 seconds after the H0 at the initiation of the boosters. Ariane 5 will then head towards the east to separate the satellites on an equatorial plane. The perigee altitude will be 250 kilometers, and the apogee altitude will be 35,786 kilometers. Elasat 3 Inmarsat SEAN will separate first, 28 minutes and 17 seconds after liftoff. GSAT 17 will then separate 10 minutes and 44 seconds later. Our launch is imminent. Go Ariane 5, go Elasat 3, Inmarsat SEAN and GSAT 17, and of course, enjoy the show.
Just under 12 minutes until liftoff. All is go for the launch this evening. Mission time tonight is 39 minutes. That's relatively short, but there's a lot of action packed into those 39 minutes, so we hope you stay with us. This is the 4th launch of the year, as Stefan said, for Ariane Space with the Ariane 5 vehicle. Remember, the Ariane 5 is the reliable workhorse member and the senior member of the Ariane family, designed for heavier satellites and for double launches like tonight. We want to move outside and take a first look at the launch vehicle. For those of you unfamiliar with the Ariane 5, there are 2 versions. The one we're using tonight stands 54 meters tall. She's in 2 parts. They call them composites. There's a lower composite and an upper one. The lower composite including the main stage and the boosters, and the upper composite with a single engine and the 2 satellites. We'll be describing each in turn as it's functioning, so you can follow along as Ariane 5 makes her way across the Atlantic. More on the upper passenger, Elasat Inmarsat, in the first of many films, coming up right now.
This condosat mission, dedicated to aviation connectivity for the Inmarsat payload and telecommunication for the Elasat payload, was integrated from contract signature up to launch in a record time of little less than 7 months, which shows the efficiency and agility of Arianespace and the Ariane 5 launch system. For Elasat, a member of the Arabsat group, HS3IS will be the first satellite to be launched by Arianespace, with another satellite, Elasat 4, to launch next year on Ariane 5. For Inmarsat, one of our long-time customers, HS3IS will be the 9th satellite to be launched by Arianespace, with the first one, Marex-1, which was launched in 1981 on Ariane 1, and the last one, AlphaSat, which was launched in 2013 on Ariane 5. HS3IS, which is built on the Spacebus 4000 C4 platform, will be the 149th Thales Arianespace satellite to be launched by Arianespace, with 8 other satellites in our backlog. Thanks again to our two customers, Inmarsat and Elasat, for their confidence in Arianespace to launch HS3IS.
Less than 9.5 minutes to go now. Ariane 5 waiting patiently like the rest of us for her big moment. The weather was chancy this morning, but all seems to be in order, and we should have a fine launch. We're coming to you live, as always, from the Jupiter Mission Control Building, which is the nerve center and the heart of the space base here. Behind the glass behind us here, the workstations are staffed by teams in charge of the launch of the satellites and the base facilities. The room divided, as you can see, in two parts, technicians and VIPs on this side. We saw a film on our first passenger. Take a first look at our second passenger now, GSAT 17 for Israel.
The launch is taking place from Guyana Space Center in French Guyana, that is
ISRO,
in
the Indian Space
northern
Research Organization,
South America.
in charge of developing and operating the Indian domestic satellites, has been one of the earliest and one of the most faithful customers of Arianespace. GSAT 18 was launched a few months ago on board the Ariane VA238 launch, and we shall be launching GSAT 11 in the coming month. GSAT 17 is the 9th satellite in the Ariane series that is being prepared here in CSG and Arianespace facilities. Therefore, all the particularities for the preparation for launch in the processing are very well known by our teams. This is a great advantage for streamlining the operations. So thank you to ISRO for its continued confidence, and all the best to GSAT 17 for its mission.
The countdown is proceeding smoothly. 7.5 minutes to go to liftoff with Elasat, Inmarsat, and a GSAT. You can see we have a red on the... You
se tiennent prêts à la reprise de la chronologie à H0-7 minutes en cas de retour au vert.
Now we do have a delaying factor, however we do not know how long exactly it will delay the launch.
À tous de DDO. Suite au retour au vert du rouge, ensemble de lancement, le nouvel H0 visé est 21h15 minutes. Le temps des comptes redémarrera à 21h08 minutes TU. À tous de DDO, attention pour la reprise du temps des comptes. Top H0-7 minutes. Le nouvel H0 visé est 21h15 minutes TU.
We're back in action after that brief delay. We had a hold in the countdown. We'll have to wait till tomorrow, I guess, to find out what it was. But we want to show you some of the other key players. You have Mission Director Davy Vranken and the Range Operations Manager, the DDO. That's his voice you have been hearing. We're going to go to the launch campaign. You can see how Ariane 5 is put together for her mission.
We are now close to the end of the VA238 launch campaign, which began for the launcher activities on May 17 in the Launcher Integration Building. After handing assembly, electrical and propulsion subsystem checks, the launcher was transferred June 12 in the final assembly building.
The satellite campaign for this Ariane 5 launch, with GSAT 17 and HS3IS as our passengers, started about 7 weeks ago. GSAT 17 arrived in French Guiana on board an Antonov airplane and was transferred to the S5 facilities in the Guyana Space Center. Specific to this satellite campaign are the deployment tests which are performed on the solar arrays and the payload reflectors. After the preparation phase, the GSAT 17 satellite was transferred to the fueling hall, where the satellite was filled with the bipropellants MON and MMH. HeliSat 3 Inmarsat SEAN, or in short HS3IS, arrived at the Félix Éboué Airport in Cayenne. HS3IS started their campaign with an electrical checkout of the satellite before being transferred to the fueling hall. Also, this satellite was filled with the bipropellants MON and MMH before being finalized for launch. After the preparation phase, both satellites were integrated on their launch adapter and were transferred to the BAF building. Upon arrival, the upper passenger HS3IS was integrated onto the Silda structure, which allows a dual launch configuration on an Ariane 5 rocket. The following day, the fairing was integrated over the HS3IS satellite, which completed the upper composite integration. The GSAT 17 satellite was subsequently integrated onto the launch vehicle, and the launcher upper part was finalized by integrating the upper composite, including the HS3IS spacecraft, over its co-passenger onto the launcher.
The preparation of the launch will conclude its fourth Ariane 5 launch campaign in 2017 and the seventh till the beginning of the year. I thank all the launch team for its involvement in the success of this goal.
Seventh launch of the year for Ariane Space, and we're only in June. Well, there they are on the right, the green status panels, which tell the story. We had red just a moment ago. Now they're the color that we prefer. They are a real-time summary of all the launch activities here on the base, the launcher and the satellites, of course, but also services like telemetry, radar, safety, the weather, and the ground facilities. And we check them before lifting off, and we go in all of them already and not before. These panels tell us about the readiness of the main systems involved. And as you saw a moment ago, that wasn't the case. We had a red on an authorization to launch, but we're back in business now. Some 1,700 people are working around the space base in all. Another place besides here in Jupiter that is very busy at this hour is the launch zone, where the launch management teams are working under the direction of the launch operations manager, tonight Patrick Lucet. Right now up there, two teams are working. One is responsible for the ground operations, the other for readiness of the Ariane 5 vehicle. The launch site operations manager heads up one group, and he coordinates with Jupiter Mission Control here for final authorization to launch. And when all the conditions are right, he then okays the automatic sequence at the 7-minute mark, which we just saw. In all, about 100 people hard at work up there in launch control, going over the final checks and the final verifications on all parts of Ariane's launch system. And these checks go right down until liftoff time. 2.5 minutes to go until launch of our 94th Ariane 5 mission. And here in Jupiter, very shortly, the VIPs and the invited guests are going to start to make their ways outside to watch the liftoff. There are two terraces here on either side of the building that give a fine view onto the pad. And if the skies are clear, which they look clearer than this morning anyway, the visitors will have quite a sight. Here in Jupiter are the operational teams, but in fact, to launch Ariane or Soyuz or Vega, we also need security, army, firefighters, journalists, and other professions. Split screen image here showing the propellant feeder arms in the middle of the launcher, liquid hydrogen on the left, liquid oxygen on the right. What are they doing? Well, they're putting propellant into the upper stage tanks. And you'll see these arms pull back at about 5 seconds before ignition, and the arms you can see in the middle of the gantry, the yellow bars going into the upper stage. This is one of the last things you see before liftoff, that is, so we like to take a minute and mention it. Minute and a half to go. GSAT 17 arrived here on May 15th and went right to the satellite preparation buildings. Inmarsat Helisat arrived the week after on May 23rd. And began its tests. You're going to hear the DDO call out the one.
À tous de DDO, attention pour moins 1 minute.
All those tests now to ready the launcher are over. Everything that has had to be done has been done.
Top à 0 moins 1 minute.
We're into the final 60 seconds. Give us a chance to say hello to our friends at ISRO in Bengaluru, to our friends at Arabsat, to Inmarsat tonight in London, Helisat people in Athens and in Larnaca in Cyprus, to the Thales Alenia space teams in Cannes and Toulouse. Hello locally to the Kourou, Sinnamary, and Cayenne sites, to our industrial partners, ISA and CNES, and to all of you following the broadcast on the internet. We hope you are enjoying it. If you're not settled in, pull up a chair and enjoy the launch, because we're going to cut away and let you listen to the DDO, and he will call out the final seconds. Remember, the cryo arms will open at about -7 seconds.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage UAP, décollage.
And we have left off.
Les paramètres bord sont nominaux.
So at 17, what is it, 17:15, 18:59, right on time, well, with a 5-minute delay. Ariane 5 began her mission, lifting off
La propulsion est nominale.
in French Guiana with a lot of fire. Nice shot of the birds on the port side as she took off. I don't know if you could see that. The DDO is saying that everything is going smoothly on board as Ariane begins her mission, the 7th for Ariane Space.
Tous les paramètres à bord sont normaux.
2 new satellites
Supersonic approaching
for
max
new
Q.
services for new customers around the globe. The 2 boosters are providing 90% of our thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 774 tons is her mass at liftoff. She's burning 5 tons of fuel per second, 2.5 tons in each booster, plus the core stage in the middle is burning another 300 kilos of fuel every second. And Ariane 5 now following the program in her onboard computer, which is located on the upper stage. This gives all the orders, including stage separations, which we will
La propulsion est nominale, la trajectoire est nominale, tous les paramètres à bord sont normaux.
Propulsion and trajectory normal, says the DDO. We're in the first of 4 flight phases. We'll describe each in turn and in detail so you can follow Ariane as she heads east across the Atlantic. Right now, the first flight phase. The single first stage engine and the 2 boosters are burning. The boosters will each consume 240 tons in just over 2 minutes, another 20 seconds roughly for them to burn. They'll be the first to be extinguished. You'll hear that also,
Tous les
of course, from
paramètres
the
à bord sont
DDO.
normaux.
We're 15 kilometers from the pad here in Jupiter, and the sound is just
Séparation
coming
des
over.
2 EAP.
And we have booster
All right, those are
separation.
the separation of the 2 boosters. You saw that. The DDO confirmed it.
By now,
This is what it looks like up
first
there.
stage
There's
has burned
one
so much fuel that
on
it
the
cannot
left-hand
really
side
lift
of the
its weight
vehicle,
on its own.
outside of out of the camera range.
This is
Before the
essentially
boosters
the
are
point
empty,
of
their
lowest
push
thrust
diminishes,
weight
and the
ratio.
onboard computer, the same one, senses this drop in acceleration and separates them. And they fall 500 kilometers from shore into a protected area. French Guiana was in part, remember, chosen
Tous
as
les
a base
paramètres à
for
bord
its
sont
opening
normaux, la
on
propulsion est
the ocean.
nominale.
Launches posing no threat to local population. Take a look at the bottom of your screen. On the left, altitude, on the right, our speed. We're over 100 kilometers, and we're past 2 kilometers per second. We're getting close to the separation of the fairing, which will be next up. And there we are, right on time.
Séparation de la coiffe.
Kilometers. Revealing the silver box on the top is Hellasat Inmarsat. Separation is given by 2 pyrotechnic cords, and there's one half you can see, the other half on the right side out of camera range. These cords actually remove the fairing by a contained explosion, very small explosion, that pushes the 2 parts of the fairing apart. We can separate the fairing now. Why? Because we're out of the dense layers of the atmosphere, and neither friction nor heating, which could disturb the passengers. Also, we can get rid
La
of any dead
propulsion
weight.
est nominale.
The fairing weighs almost 2.5 tons, so we don't need it anymore. We let it go. Ariane 5, of course, the heavy lift launch vehicle. The other 2 members of the family, Soyuz, lifting middle-sized payloads, 2 and 3 tons. And Vega, the light lift vehicle for
La
missions of
trajectoire
1
est
ton.
nominale.
Our next film gives you a closer look at one of our upper passenger operators, Hellasat 3.
Welcome to the Hellasat world, your gateway to satellite services right in the heart of Europe.
And liftoff of the Lockheed Martin Atlas V rocket, carrying the first satellite for the countries of Greece and Cyprus.
Hellasat is a premium satellite communications solutions provider founded in 2001 and acquired by Arabsat in 2013. Its powerful orbital position at 39 degrees east makes Hellasat organization an established brand name in a highly competitive satellite environment. With ground facilities located in Greece and Cyprus, Hellasat provides end-to-end, reliable and supreme quality satellite services in Europe, South Africa and the Middle East.
A high-skilled team of satellite network engineers in Greece and Cyprus provide our customers with fully reliable services that meet their communication needs when and wherever is required.
Hellasat serves leading DTH operators, by delivering content to more than 3 million households while providing cost-effective solutions to enterprises and governments that want to expand connectivity to every location of their network in the coverage areas.
Our focus is to provide solutions to our customers through our satellites in Europe, Middle East and South Africa.
As of June 2017, the new geostationary satellite HelasSat-3 will offer service continuity and expansion over 39 degrees east until the end of the year 2034.
HelasSat-3 Inmarsat S is a joint venture between Helasat and Inmarsat. The Helasat payload will operate 47 Ku transponders and 9 8K channels covering Europe, Middle East and South Africa. The HelasSat-3 Inmarsat S satellite is based on the Spacebus 4000 C4 platform and is one of the largest satellites manufactured by Thales Alenia Space.
The launch and operation of HelasSat-3, to be followed by HelasSat-4 in 2018, are proof that HelasSat is becoming year by year a more powerful and competitive satellite organization, providing further flexible, scalable, and efficient HelasSat services to an even greater market across 3 continents.
Greece and Cyprus, from the ancient times, were the crossroads of civilizations and the crossroads of trade between Middle East, Africa, and Europe. Our ambition is HelasSat to play this role, to be the window of Middle East and Africa to Europe.
At HelasSat, we believe that leveraging our deep expertise to provide fast, reliable, and cost-effective solutions to our customers is at the core of everything we do. HelasSat, growing connections, brighter horizons.
The film mentioned HelasSat-4 to be launched next year. That new satellite will be launched also by Ariane Space. We should have a launch replay coming up for you.
By
Here
now,
we are. That's the first one.
First stage has burned so much
We have
fuel
several
that
shots
satellite
of
using the
the
tiny
launch
first
vehicle's
stage
replay. You
engine
can relive
has
those
a
moments
thrust rate ratio of 2.
as Ariane 5
The
took
rocket
off
acceleration
from the
at 20
pad close to
meters
8
per
minutes
second
ago.
squared.
We have cameras at several of the half-dozen observation sites that are stationed at the base, and they furnish us with shots from different angles. Here's the second one. We should have more. I think we're going to have a third one. The closest observation site is called Toucan, like the bird, and many of our VIPs are out there tonight, and that's closest to the base, about 4 kilometers. Wonderful view. We're in the second powered flight phase. The single engine core stage is burning now. While you were watching the film, we were also picked up by our first downrange tracking station in Natal over the border in our neighbor, Brazil. A fast mission tonight. HelasSat Inmarsat will be on station in just 10 days. Michele Franchi of Inmarsat this morning told us that last month they launched from Florida, and the satellite won't be on station until early August because the mission's different, involving electrical orbit raising and such things, but not today. They're going to be right there in a week and just a few days.
Extinction de l'EPC sur commande de guidage.
There you saw the extinction of the lower stage and the separation, and watch the nozzle on the upper stage. There it is, turning right on. These 3 commands, extinction and separation of the lower stage and ignition of the upper stage, given by the onboard computer in about 13 seconds. And our onboard camera giving a shot of the lower stage falling back into the Atlantic off the Gulf of Guinea. We are now in the third powered flight phase, the single upper stage engine that'll burn until plus 25 minutes, or 16 minutes roughly. Job of the upper stage is to take the satellites to their injection point, position them for separation, and then release them. That's its propulsion role, but it has a second role that comes during its ballistics phase, and we'll get back to that in a while. Our next film, another look at our first passenger, this time on the Inmarsat side.
And we have now, just after first stage separation, almost reached the low orbit velocity, or the minimum
satellite and complementary
orbit.
ground network across Europe.
Satellite is now basically in orbit, but not in its destination
of a
orbit.
visionary and unique commercial and technological opportunity created by the European Commission's DG Connect and subsequently supported to the hilt by 28 member state telecoms regulators. This new network, we said, would uniquely combine space-based and ground-based infrastructure to build a seamless, integrated network across the whole European Union that would deliver the most advanced aviation passenger Wi-Fi experience anywhere in the world. No network like this has ever been built before. And so the idea of the European Aviation Network, or EAN, was born. What we and our partners have achieved in just 36 months from that date is, frankly, amazing. We've commissioned an S-band payload from our partner Thales Alenia Space, which is today being launched into an orbital slot over Europe by Ariane Space. And we've constructed and fully tested the satellite ground infrastructure. We've also built a unique strategic partnership with Deutsche Telekom, one of the world's leading integrated telecommunications companies, to design, build and maintain the LTE-based ground network and to be our preferred provider of ISP services across the EAN. Deutsche Telekom continues to make good progress with the build-out of this complementary ground component network covering the highest density airline routes. We signed international airline groups, which includes world-renowned airline brands such as British Airways, Iberia, Aer Lingus and Vueling as our launch customer for the new service. IAG plans to equip in excess of 300 aircraft with our EAN service and aims to have 90% of its short-haul fleet ready for commercial service by early 2019. And if all that wasn't enough, we've also secured all 28 EU territory mobile satellite service authorizations, plus Norway and Switzerland. And 27 countries have to date provided us with authorizations or in-principle approvals for the complementary ground component. To have done all this in just 36 months is a testament to the skill and dedication of multiple teams across Inmarsat and to the strength of our world-class network of partners. So today, with the launch of Inmarsat S-EAN, we see the plan for the European Aviation Network achieve another key milestone. The hard work, of course, is far from over. During the coming weeks and months, we will place the satellite into its orbital position before commencing a rigorous series of tests. In parallel, Deutsche Telekom will continue rolling out the complementary ground component across 31 countries in Europe, while our manufacturing partners complete production of the integrated satellite and air-to-ground avionics, which will enable EAN to operate as a fully integrated service. All this effort is focused on turning the concept of the European Aviation Network into the reality of an operational commercial service in the second half of this year. I'll conclude by offering my sincere gratitude to all my colleagues at Inmarsat, our engineering teams, our regulatory teams, our aviation team, and many, many others who have worked tirelessly, not just to deliver a unique service that will transform the experience of airline passengers throughout Europe in the years to come, but to have achieved so much in just 3 years. And finally, I must also offer my thanks to our vital EAN strategic partners, to Deutsche Telekom, Thales Alenia Space, Thales Aviation, Cobham, and of course, today of all days, our trusted launch provider, Ariane Space. Thank you.
While you were watching that film, we were picked up by our next downrange tracking station, Ascension Island. Tiny island out in the South Atlantic, 10 square kilometers, belongs to the UK. NASA had a station there till 1989. When they closed it, ESA decided to build its own. All of Ariane's trajectory has been designed to be followed from the ground. The launcher sends radar and telemetry back to this network of stations that keep constant watch on the health of her systems. Ascension Island, Natal before it, and others to come. A final film on Hellasat Inmarsat for you now, with a look at its builder, Thales Alenia Space.
European airline passengers will soon be able to watch YouTube on the plane or surf the web thanks to the partnership between 4 parties. The strong ties between ourselves at Thales Alenia Space and Inmarsat, Elasat and Arabsat have been instrumental in bringing Inmarsat S-band Elasat Sat3 to fruition. We have developed a powerful and high-performance satellite with a unique combination of mobile, broadcast, and fixed satellite services, using Thales Alenia Space Spacebus 4000 platform. Inmarsat S-band mission will deliver, as a complement of GX constellation, in-flight internet to rival what we get on the ground. The Elasat-3 mission will provide advanced telecom services in Europe and Africa. I want to thank everyone involved, all the partners, and Ariane Space. This venture will transform passenger connectivity over Europe and the high-definition broadcast from 39 degrees east. Everyone at Thales Alenia Space joins me in wishing Inmarsat, Elasat, Arabsat, and their customers the very best for these exciting missions.
Couple of minutes left in the upper stage burn. Cutoff due, remember, at plus 25 minutes. Inmarsat and Helasat sharing what they call the condominium satellite. Two independent missions on one satellite doesn't happen every day. So for this mission, we have 2 satellites, but 3 customers and 3 clients for flight number 238. One of them, Inmarsat, the International Maritime Satellite Organization, and this is the 9th satellite Ariane Space has launched for them. It's the very first launched for Helasat. We're going to turn to our second passenger, a first film now on ISRO and GSAT 17.
Communication satellites have revolutionized telecommunication and broadcasting services worldwide. Many services today, such as television broadcast, telephoning, radio networking, internet, banking communications, rely in varying degrees on these communication outposts in deep space. Starting with the direction provided by the great visionary Dr. Vikram Sarabhai in the 70s, satellite instructional television experiment was our first twist of television broadcast through a communication satellite. With sight, television entered the home of the common man.
It will be our constant endeavor in the years to come to provide the peaceful uses of outer space for the real problems of this nation.
What followed was nothing short of a revolution. With its series of Inmarsat and GSAT communication satellites, ISRO strongly went forward on these lines, serving various needs of our nation. While some of the Inmarsat satellites carried both communication and meteorological payloads, the GSAT series is dedicated to communication services only. GSAT 17 is ISRO's indigenous communication satellite, built on its proven I-3K spacecraft bus or platform. It will provide continuity to fixed satellite services in C and extended C-band and mobile satellite services in S-band, which were provided earlier by the older Inmarsat satellites. GSAT 17 is structured around a 3.1-meter carbon fiber reinforced plastic central cylinder, which houses the oxidizer and fuel tanks. North and south panels of the structure accommodate the majority of payload and bus system packages. These have embedded heat pipes for efficient thermal management. This 3,475 kilogram spacecraft carries payloads in C, extended C and S-band. It also carries a data relay transponder and search and rescue payload. One lower extended C-band transponder will provide connectivity to Antarctica. 2 deployable dual-graded reflectors are mounted on the east and west sides of the spacecraft. The Earth viewing site contains a short backfire antenna, MSS band prime focal reflector antenna, and 2 microstrip patch array antennas for payload. It also has a global horn and an omni antenna for telemetry tracking and command operations. The spacecraft has deployable solar panels for generating electrical power. These are mounted on the north and south sides of the structure. These panels contain advanced triple junction or ATJ solar cells, which have the capacity to generate around 6 kilowatts of electrical power. The 2 solar array drive assemblies are used for maximizing solar flux on its solar panels by continuously orienting the solar panels towards the sun. The lithium-ion batteries will provide essential power to the payload and bus systems during periods of eclipse. Upon its launch, the satellite will be injected into an elliptical geotransfer orbit in which its shortest distance from Earth, called perigee, will be around 250 kilometers, and its farthest point from the Earth, called apogee, shall be around 36,000 kilometers. The liquid apogee motor of the satellite will then be fired to raise the perigee of satellite to 36,000 kilometers, which will make its orbit circular and geosynchronous. This is called orbit raising maneuver. The satellite contains approximately 1,925 kilograms of propellant for its orbit raising, as well as for station keeping corrections by its attitude and orbit control system during its lifetime. The creation and assembly of this satellite has been a collective effort of Team ISRO, spread across the country. ISRO Satellite Center, ISAT, Bangalore, did the configuration design, development of many bus systems, testing and assembly of the spacecraft. Space Applications Center, Ahmedabad, realized the communication payload. Many other subsystems like inertial elements, sensors, propulsion, composites, etc. were delivered by IISU, LEOS, LPSC and VSSC respectively. Many industries also produced and supplied different subsystems. Master Control Facility, Hassan, will carry out all the mission operations during expected lifetime. This communication outpost is expected to soar into space aboard Ariane 5 rocket, VA238 mission from Kourou in French Guiana on 28th of June 2017 at 20:59 hours UTC. It will be located in geostationary orbit and is expected to serve the nation for 15 years.
Less than a minute to go in the upper stage.
Il reste moins de 1 minute de propulsion de l'ESCA. Tous les paramètres à bord sont normaux.
Some other key players, other dramatis personae, these are the satellite mission directors. They decide if their satellite is ready for launch. They follow the campaign and give the okay for each stage of its preparation. All that going on here at the CSG, Europe Spaceport, the world's only dedicated commercial space base. Ariane Space operating the launcher family here, and Ariane Space having another very busy year here at Europe's Spaceport. One reason being that launches at the base are getting closer and closer together. This is thanks to a shorter and shorter time between launches, less than 15 days between most of the 6 launches so far this year. Ariane's mission proceeding on schedule. We're coming up on extinction of the upper stage. You'll see
Extinction de l'ESCA.
There we go. DDO has confirmed extinction of the upper stage right on time. So Ariane has hit her maximum speed, you can see on the bottom right, which just disappeared, but it'll come back, 9.3 kilometers per second. You see the speed.
Début des manœuvres en vue de la libération du satellite HF3IS.
At 39 minutes, she'll be down to 7.3 kilometers per second. All is functioning normally on board. You're watching Ariane spaceflight number 238. Take a look now at a film outlining the relationship between Ariane Space and Hellasat Inmarsat.
Welcome all to the VA238 launch. In December last year, Inmarsat and Hellasat have entrusted Ariane Space with the launch of their condosat mission, Hellasat 3, Inmarsat S EAN, so-called HS3IS.
It has been a real win-win for Inmarsat and Hellasat to develop this project together. I would like to thank Hellasat, Arabsat, and TAS for this great journey so far. It was really enriching for me and for Inmarsat. I would like to thank all my team for the outstanding job done. Great job, guys. The Inmarsat S-EAN payload main mission is to deliver communication services in the S-band to support Inmarsat European Aviation Network that will deliver high-capacity in-flight broadband for airline passengers across Europe. This is another great example on Inmarsat capabilities to develop complex systems for mobile application.
The HS3IS satellite will be Hellasat's second satellite at 39 degrees east, delivering in-orbit, direct-to-home, and telecom services over its coverage areas in Europe, Middle East, and Sub-Saharan African countries. Its activation will not only maintain, but also expand Hellasat's business reach with additional capacities while bringing video content in high and ultra-high definition format.
The spacecraft that was manufactured by a very competent team at Thales Alenia Space in Cannes and Toulouse is a very good example of a condosat, where two payloads for two different customers share the same bus.
The success of this project is a result of strong commitment by teams of people, not just within Hellasat and Arabsat. On behalf of Hellasat and Arabsat, our sincere thanks to Thales Alenia Space for an excellent job done in the manufacturing and delivery of the satellite, to Ariane Space for an impressively fast preparation for launch, and finally to Inmarsat for great collaboration and partnership in this condosat project over the past 3.5 years.
We are extremely happy with the very fast integration cycle that allow us to be ready to launch in such a fast turnaround. All the work was just done in less than 7 months.
We are coming up on confirmation from the DDO on separation of our upper passenger, due in just about 10 seconds.
Début de mise en spin au profit d'HS3IS.
Moment of high concentration here. The teams have gone through these procedures before, but it does call for tremendous focus. All eyes are on their computer screen.
Séparation Hellasat 3, Inmarsat S EAN.
Yeah, there you are. The first good news of the evening, successful separation of our first passenger, and you can see her leaving the mothership. Hellasat 3 and Inmarsat S EAN right on time, separated off of the coast of Africa. You may notice that the people here in Jupiter are politely holding their applause because the mission is not over. We still have to separate our final passenger, GSAT 17, but the handshakes have occurred, and there'll be more of those at the end of the mission. The separation mode, you might have seen, longitudinal spin, minus 1.5 degrees per second. The composite is spun counterclockwise. Now that Hellasat Inmarsat is up, some of its early maneuvers: telemetry acquisition in 11 minutes from its Mingenew station, Australia. Initial sun acquisition 2 hours after that. Partial solar array deployment 1 hour after that. There will be 3 apogee burns, we are told, on the 3rd, 6th,
La manœuvre au profit du SILDA se déroule nominalement.
The satellite will reach its position on day 5, and day 6 will see full solar array deployment, as well as the beginning of on-orbit testing, and all that handled by the new station in Nemea in Greece. Inmarsat opened this station in the Peloponnese 2 years ago as part of its European aviation network. Coming up on separation of the SILDA, this, remember, is the structure that lets us carry a second passenger. We've used the SILDA or an
Séparation du système de lancement double Ariane 5, autrement dit SILDA.
You can see there's its separation, the black bell-shaped structure, revealing GSAT to the elements. Total weight for the 2 passengers today, 9.2 tons. Both have 15-year lifespans. The 2 passengers today are the 190th and 191st to be launched on an Ariane 5. And the 423rd and 24th to be launched on an Ariane vehicle, because remember, Before Ariane 5, there was Ariane 1, 2, 3, and 4. Hellasat Inmarsat is the 149th satellite built by Thales Alenia Space to be launched by Ariane Space, and there's 7 more Thales Alenia satellites in the Ariane backlog waiting to be launched. You may have heard that Europe is developing a successor to Ariane 5, very big news. The decision taken by ESA in 2014 develop Ariane 6, more market-driven vehicle to meet customer needs and market changes, including electrical propulsion. It'll apparently be half the cost of Ariane 5 per kilo in 2 versions, 2 or 4 boosters, one institutional and one commercial. Now that the satellite is up, let's hear a bit more about its first maneuvers. We'll be back with more in a moment.
Following a successful injection into a geostationary transfer orbit, Thales Alenia Space will assume control of the satellite from its control center in Cannes. With support from Inmarsat and Hellasat engineering teams, Thales Alenia Space will conduct a series of health check and subsystem initializations and activations to complete a set of apogee maneuvers and bring the satellite to its first geostationary position within 5 days. Once there, the solar arrays will be fully deployed, followed by the deployment of all reflectors. With completion of the first set of in-orbit tests commanded by a ground station in Nemea, Greece, the satellite will drift to its final position at 39 degrees east, complete all remaining tests, and begin its operational life.
Separation of GSAT in about 7 minutes from now. The upper stage is coasting now. We're out of our propulsion phases. It has a dual role. Propulsion came first. Now this ballistics role. With extinction of the upper stage, her propulsion part is over, and she's carrying out the second role. We are coasting, and the composite is being spun counterclockwise in a series of operations. You can see some of that on the screen. These maneuvers range in time from a few seconds to a few minutes. And all this why? Well, we have to separate the first satellite in one direction and one altitude. Hellasat Inmarsat was separated at 1,200 kilometers. Then we separate the Silda, which you just saw, in a second direction and another altitude higher, 1,500 kilometers. Finally, GSAT has to go in a third direction at altitude, and she is separated at 3,600 kilometers up. All this also to avoid risk of collision. Space ballet, they call it. The attitude and control system uses small thrusters to perform these maneuvers. You might be able to see them pop on and off on the screen. We have a moment. We want to turn to the quiz question, see if anybody from our 2 passengers organizations can get this one. Quiz question number 238. Listen up. This is not the first time ISRO and Inmarsat have flown together on an Ariane space flight. So our question is, before tonight, when did they share a launch? Get back to you with the answer in a moment. In our next film, we take a look at the relationship between Ariane Space and ISRO.
With GSAT 17, more than 20 ISRO-built satellites will have been launched by Ariane, and we are very proud of this continuous cooperation.
GSAT 17 spacecraft is a multi-band communication spacecraft with payloads operating in normal sea, upper extended sea, and lower extended sea bands. It also has a mobile satellite service transponder operating in S-band. Additionally, the satellite also carries payloads for data relay as well as search and rescue services. For the first time, MSS payload is designed with a digital filter which provides reconfigurability in frequency spectrum and sharp cutoff filtering, which will significantly help in operations. GSAT 17 is the heaviest spacecraft built by ISRO and is designed for a lifetime of 15 years. The spacecraft generates about 6 kilowatts of power and weighs around 3,475 kg at liftoff. The launch campaign at Guyana Space Center has been very smooth with a very professional approach from ISRO, Ariane Space and Canes teams. The teams also shared a very cordial relationship and had interesting cultural exchanges too.
Remember, our mass at liftoff was 774 tons. What's left of that, do you think? Take a quick look. The vehicle lost 240 tons of fuel in each booster. That was 2 minutes after liftoff. Then came the first stage. She used up all the 175 tons of propellant in that, plus another 14 tons of dry mass that was the lower stage. That was also shed. Then we separated our first passenger, 5.5 tons. Then the sill to 0.5 ton. So what's left of 774 tons? Count it. The upper stage, 19 tons. The vehicle equipment bay, that's the white band in the composite, 1 ton. GSAT weighs 3.5 tons, 3.4. Some adapters, a couple hundred kilos, so roughly 25 tons. Remember, 9 tons placed on orbit, down from 774 tons. Most of her weight, you realize, is propellant. Another place on the space base where people are very busy tonight, the CVI, the Quick Look Telemetry Display Control Center. These teams have all the means for receiving, processing, storing, and analyzing all the data coming in from the ground stations along Ariane's flight path. Remember, we talked about the downrange stations. Now, right now, these teams are following and analyzing all the key flight data coming in, and they're reporting the flight status of the vehicle back here to us in Jupiter. This is why Jupiter is called the nerve center of the space base. Later on, these data will be treated to reconstitute the entire mission. The flight will be recreated in figures from liftoff to well after satellite separation and analyzed again. We are still in what they call the coasting phase, also called the free flying phase. On the animation, you're over the continent of India. And when we get back to the map, she's flown over the Hassan station, which is on the coast. We'll get another look at it. But for now, our final film, giving a rundown of GSAT's first maneuvers after its separation.
Soon after separation, GSAT-17 spacecraft will be tracked by Master Control Facility Hassan Ground Station. The Ariane launcher will place the spacecraft into elliptical geo-transfer orbit of about 36,000 kilometers by 250 kilometers. The spacecraft will be put into circular geosynchronous orbit of about 36,000 kilometers by firing its own apogee boost motor 3 times around 26 hours, 56 hours, and 78 hours after separation. Subsequently, solar panels and reflectors will be deployed, and 3-axis stabilization of spacecraft will be achieved using momentum wheels. Afterwards, station keeping maneuvers will be carried out to park the spacecraft in its designated orbit of 93.5 degree east. Detailed in-orbit testing of payload will be carried out before declaring the spacecraft operational.
Less than a minute until separation of GSAT at 39:01. Separation, of course, marks an end as well as a beginning. It's an end to the launcher's mission, but the start of a lot of work for the ground crews around the world who will monitor and track the satellite, test it.
Les manœuvres d'orientation au profit du GSAT-17 sont terminées.
So those teams getting ready to take over, while here, a moment of high concentration as the teams await confirmation of separation of our second passenger. The mood here in Jupiter, I would say, very focused.
Séparation GSAT-17.
So, the final good news, and you heard the applause from the people here in Jupiter as Ariane 5 has delivered her second passenger, GSAT-17, out over the Indian Ocean. And you saw the separation different from the first passenger, GSAT-17 separated via a 3-axis stabilized mode. So, from the tense minutes just moments ago, you can see the change here in Jupiter. Handshake, smiles, very buoyant all across the Space Center. And equally at all the points and posts where people are following the launcher and the satellite, work is just beginning or soon will be at the different ground stations for both Hellasat, Inmarsat, and for GSAT, and at other sites around the world. Meanwhile, back in Jupiter, we are waiting for the traditional post-separation speeches, podium being set up for our speakers, who will include Luce Fabrigat of Arianespace, Michele Franchi of Inmarsat, Christodoulos Protopapas of Hellasat, Nikolaos Papas, Greek Minister for Digital Policy, Marios Dimitriadis, Cyprian Transport Minister, Vasileios Maglaras, Greek Secretary of State for Telecommunications, Bertrand Moreau of Thales Alenia Space, and Dr. Sylvan of ISRO. Some of these people are seated on the VIP side, the outside of Jupiter, but Luce Fabregat and some of the others have been working on the inside, and they will shortly be making their way out to join us on this side of the glass. Answer the quiz question if you got it. This is not the first time ISRO and Inmarsat have flown together before tonight. When did they share a launch? Twice, actually. Flight 97, June 1997, on an Ariane 4, Inmarsat 3F4 and INSAT 2D. And Flight 214, more recently, an Ariane 5, AlphaSat and INSAT 3D. So, if you got the answers to one or both of those, give yourselves a round of applause, and you will get to see another launch replay coming up at the end of the show, and you get to hear the speeches. Meanwhile, up in space, what's happening with Ariane 5? Well, after separation of our second passenger, what is left of the composite, remember is not much, is spun up again in a different direction, which is called, for what is called passivation. This involves emptying first the liquid oxygen tank, then the liquid hydrogen tank of any remaining fuel, and this takes place at a much higher altitude, somewhere between 4 and 5,000 kilometers up, and that represents the very end of the Ariane mission, but it's something that we will not see. What we will see are the speeches. I believe Luce Fabregat will be first, Ariane Space's Executive Vice President. While we're waiting, we'll go to another launch replay.
Now we will still be seeing the replays. I will cut off the live stream before the speeches, which will carry out quite long.
200.
That's typical for Ariane space broadcast. I will, however, upload a full version of
because I see
the
Luce
webcast later on.
making her way to the podium.
Now
she will begin
next
a series of
live stream will
speeches.
be that of the next Falcon 9 flight, which will be on July 2nd, as it's currently planned.
Will be the next voice you hear.
Well, for now I will show another replay, then stop this live cast after waiting for a few more minutes, and set it back up to the 24/7 ISS broadcast. Now we have a very successful flight, and I will show another replay of the launch before ending the live cast. So this will conclude today's live stream. I will put up the full webcast later on. The next live stream will be the Falcon 9 launch, now scheduled for July 2nd, although it might still be postponed. It's still a not very fixed schedule. It was originally scheduled for July 1st. I will now conclude this live stream in a few minutes and set it back up to the 24/7 ISS live stream. However, you can still ask any questions in the comments or the chat of the ISS live stream. And as always, thanks for watching.